Good morning, all. Within 10 minutes, we will start. At 10 a.m., we will start the session. So wait for some more time.
Post hernia.
Yes, good morning all. Welcome to this session. So jointly organizing by Pantech e-learning in association with MEENAKSHI Sundararajan Engineering College, Kodambakkam, Chennai. So Department of EEE organizes the national level workshop on electric vehicle using electric vehicle design using MATLAB software. So for technical sponsor, IEEE Madras chapter, our sincere gratitude to the Dr. Babai, Secretary, Meenakshi Sundararajan Engineering College, and also Dr. N. Kumarappan, Chairman, IEEE Madras section. So thank you, sir. And our sincere thanks to for organizing this workshop to the convener and Mrs. Soundarabala, head of the department, EEE, Meenakshi Sundararajan Engineering College, and all the coordinator, A.S. Manikandan, EEE department, MSc, and G. Gayatri and K. Bhaskar. So welcome to all the participants. So in this 3 days workshop, we will discuss about the e-vehicle. So in the e-vehicle, as an electrical engineer, what we people can implement by using the MATLAB SIMULINK software. To make an electric vehicle, we need to go with the step by step. So before that, we need to ask ourselves, when you people are realizing the thought, when you are imagining the electric vehicle, what you people will initially, which thought you people will raise in your mind. So how you are imagining, so according to that, how you need to build the vehicle. So to build that vehicle, so that particular application you people will work as an electrical engineer, you people will work specific application only. So what are those components in the electric vehicle? How to charge the electric vehicle? What are the batteries we people are using? We will see here. I hope everyone doing fine in this pandemic situation. The content here we will discuss coming 3 days about the history of the electrical cars. Wait a second. So electrical vehicle cars for a thought. Myself, Srinivas Lovala. I am working as a MBD engineer in Pantech Solutions. I completed my MTech in JNTU Anantapur. So from past 4 years, I'm working in Pantech Solutions. So the content here, we will discuss about the history of the electrical cars. And in 2020, we people are gathering through this platform and we are talking about the electric vehicle, right? So, but when the thought was entered in this world, the innovation, when it is initially started, now which stage we people are living, and what are the major components of the electric vehicle, and what is traction inverter, what are the types of the batteries the automobile companies are using in the electrical vehicles. And to charge your electric vehicle, we people are all charging we are using the mobile chargers, right? Like that, to charge a particular electric vehicle, to which type of charger you people will implement. So here onboard charger, a DC converter topology we need to implement, and what are the auxiliaries, ECAS, and present situation, what is the technology trend is going, and future and scope for in this particular area. Research purpose we will discuss, and what are the standards you need to follow, IEC and ISO standards, and LV124 standards we will discuss, and we will give some references also. And here, before starting about the history of the electrical cars or electric vehicle, what is the age of the technology we people are talking about? What is the age of the technology we people are talking? So here in today's world, most of the electric vehicle cars we people are seeing in our surroundings, but the initial thought was established in the globe around 150 years back itself. So the technology, the innovation, it's a continuous process. Every year the technology will change. So we need to adapt the technology and we need to move forward. So here, the history of the electrical cars, you can look at here. Here we are showing 3 figures. The first crude electric vehicle car was developed by Robert Anderson in 1832. But If you people have some thought, if you people have some thought, but when the people in your surrounding area, when they will believe you, when they will believe, if you show that one in a practical manner, the people will believe you. Initially, the thought was entered in 1832. He developed, Robert Anderson, the UK scientist, he developed this first crude electric vehicle car developed. But it takes 40 years of the time to prove in a practical manner. So 1884. So the second figure you can see here. So these type of vehicles, they're driven in roads of the UK. So the here it takes 40 years of the time to prove practical. So the our friends or the surrounding people or the whole world also believe when we need to prove that one in a practical manner. Suppose you people are trying to implement an electric vehicle car. At that point, you need to think whether in our surrounding area the infrastructure is good or not. Whether the Tamil Nadu government is providing any policies for the electric vehicle customers or the manufacturer companies and the entrepreneurs. What are the policies they are giving? The Indian government, what are the policies they are giving? So if you know those things, then the roads and the infrastructure and the roads, if you need to drive the vehicle in a fast manner, or at that point, if suppose any uh, obstacle comes when you are on the way, at that point, if you suddenly any accident happen, at that point, how you people will rescue the people in the surrounding area or inside of the vehicle. If it is an electric vehicle, then we can expect more danger because you people are using the battery. So there is no fuel if it is a battery type of electric vehicle means. So then there may be chances are there to get high amount of the voltage levels also. At that point, how the first responders, those people now any floods came, recently we faced the Never cyclone, right? At that point, the NDRF and the disaster management people only they rescue the people who are affected in the flood area, right? So like that, we need to train some people. If anything, some situation, we need to rescue the people. At that time, these people need to respond immediately, and we need to protect the humans in the surrounding area. All the people we need to save, right? So here, whatever the vehicle you people need to design. So in that vehicle, what is the requirement? Oh, the battery weight, how much, and what are the specifications of the motor, and how you need to operate. What is the range of the vehicle, the speed of the range, where how much speed you need to fix that particular vehicle. The specifications you need to analyze. But in that vehicle, which application you people are working, you need to know. But today's world, these type of electric vehicle cars we are using. Now the autopilot mode technology also introduced in the Tesla electric vehicles. Tesla electric vehicle, they are already introduced the Tesla autopilot mode. Without driver also, we can drive the vehicle in a safe manner by using auto mode pilot technology. But to whatever the vehicles we will are seeing in our surrounding in the globe, before it comes to the market, there are three steps are there. First, we need to design the model in the loop. Mill and sell and hill. These are the three steps we need to follow. So if you how you people are imagining that one you need to build in the model in the loop. So by using the MATLAB SIMULINK software, how you people are imagining, you need to build that one. Then you need to analyze the test cases. Suppose when you are driving the vehicle in 100 km speed, at the time if you are applying the brakes suddenly, then how the vehicle will trying to reduce the vehicle speed. So initially you need to control the wheel speed, then only you can control the vehicle speed. So when you are applying the brakes, then there is a feedback path. And whatever the internal, now all the vehicles, they are driven by fuels only, either petrol or diesel only. And if you people are the Indian government also, they're expecting if uh, by 2030 we people will all the Indian electric market, automobile market, they are shifted to the EV means we can save nearly 20 lakh crores of the money, Indian money itself we can save, because most of these amount we need to pay to the whatever the energy sources. Now people are using the petrol, diesel or natural, these fuel resources we are importing from the abroad countries only. 80% of the fuel energy sources we are importing from the Gulf countries only. So we need to pay to the tax to our state governments and central governments. So then another GST now we are paying, right? So that's the reason the every day the petrol prices are more increasing day by day due to international market standards, and they are increasing the prices here also. So if you are avoiding the fuel vehicles, then you people can utilize the power, whatever the energy sources, whether it is a renewable energy sources, those are all comes from the nature with free of cost, right? But how you people are generating the power with an efficient manner for your particular vehicle also. So these are the vehicles in today's world we are seeing. And the Indian market also, EV market, they are expecting by 2025 50,000 crores of the money they are expecting. The Indian EV market, they are expecting 50,000 crores. So suddenly, if you people, we need to step by step, we need to avoid the fuel vehicle. Fuel vehicles we need to avoid. Now recently, there some companies forcibly they are trying to shift it to the e-vehicles also, because of the global warming. We need to protect the environment first. We need to protect the environment. That's the reason all the global leaders and all the automobile industry technocrats also, they are mostly focusing on the electric vehicles. So when you are thinking about the electric vehicle, which type of electric vehicle you people need to work? So whether it is a hybrid electric vehicle or plug-in hybrid electric vehicle or battery type of electric vehicle. So you can see here the first ever hybrid electric vehicle cars also. The hybrid electric vehicles means the vehicle which was driven by two input sources. One is fuel and another one is battery. And in that battery place you can keep super capacitor or ultra capacitor also. If you are keeping means no issue. But this technology also, hybrid technology also introduced in the world around 120 years ago. 120 years ago, this technology was introduced. Porsche was the pioneer of this type of hybrid electric vehicle cars. Porsche was the pioneer of this hybrid technology. And here, mostly in current world, Toyota's energy drive type of vehicles we people are observing. It is from Japan, a Japanese company. So they are mostly focusing on the hybrid electric vehicle. Tesla companies, they are focusing mostly purely battery type of electric vehicles. Toyota company, they are focusing on hybrid type of electric vehicle. So you need to fix whether the battery vehicle is preferable or hybrid electric vehicle is preferable. So if there is no fuel in the vehicle means, and you can reduce the CO2 emissions easily. You can reduce the CO2 emissions, and with noiseless car also. Now you can see when we are driving the vehicle in our surrounding, due to the now everyone they are more interested to purchase their own vehicles, right? So automobile company, they are purchased due to the lockdown. They are avoiding to travel in buses and public transport. They are avoiding, and they are trying to purchase by their own bikes or own cars also. So at that point, you need to think about the pollution. So whether if you are living in a metropolitan city like Chennai or Bangalore or Hyderabad or Delhi or Bombay, at that point you need to think the metropolitan cities, they can easily carry the electric vehicles or not. So whether we can drive whether the electric vehicle we can drive safely in the roads of in our surrounding area, whether the roads are properly are maintained or not. So you can't drive like how you people are imagining, right? So when you people are thinking about these three type of vehicles, a hybrid electric vehicle, plug-in hybrid, battery type of electric vehicle, how we can implement a particular application by using the MATLAB SIMULINK software. Now you can see here high power drives here we are talking about. The electric vehicles coming years, you can, the electrical trains or cruise ship, you can see here, and the aeroplanes and here also. So to drive these vehicles, if you are using the electricity itself, so then to drive that vehicle in a high amount of the speed, which type of motor you people will prefer? Which type of motor you people will prefer? So now you can see here, we can drive the vehicles either land or air or sea only, right? So when we need to drive the vehicle in these places, so the motor, you need to know the motor, right? So whether you people are working in a electrical car company means, then if you need to build a new model car, at that point the specification of the motor you need to build, right? So now you people, I think most of the people, you are from third year or final year, right? So already you people have studied the machines you people have studied, right? The fundamental concept we people will study. Which type of machines we people will study? DC machines and AC machines. Now, when we are studying about the DC machines, and the DC machines also different types are there, AC machines also. We have two types, synchronous machines, asynchronous machines. So whether it's a electrical car or e-auto or electrical scooter or e-rickshaw or e-bike, whatever it may be. So at that point, which type of machine you people will prefer? Which type of motor you people will focus? How you are imagining? So then according to the motor only, you people will give the specification to the particular that the particular model you can easily drive with 300 kilometer speed also, because the range of the speed, the motor. So the which type of motor you people will prefer? Whether you people will prefer DC or AC? Whether you people will prefer the DC machine or AC machine? Which type
AC.
of, yeah, tell me. In someone telling DC machines, and we have two type of DC machines are there, AC machines are there. Now you can see here. So here we have DC machines and AC machines. So in AC again we have synchronous and asynchronous machines are there. So the difference here, synchronous machines are, they are running with the constant speed, and these asynchronous machines, again we have two types, squirrel cage type of induction motor and slip ring type motors also there, right? Now if you are preferring, some people are telling DC machines, they need to prefer in that particular vehicle application DC, right? If you are preferring here the DC machine, okay, let's we can take a small example about these DC machines itself. Now you can see here, so in the DC machine, DC series machines are there, shunt machines, separately excited machines also there. So if you are observing a DC machine, let's take a DC separately excited DC machines you can take. So if you draw the equivalent circuit of a DC separately excited DC machine, how it will be? Look at here. If it is a DC separately excited machine, if it is a DC separately excited machine, how the equivalent circuit you will draw? Look at here. Here, so that means DC supply. The DC machine input is DC, right? So VDC, V in, and here with a resistance, and you can add the impedance also, inductance also, and here let's take this as a DC separately excited machine. So the machine is running with, here the machine is running with 1500 RPM speed. 1500 RPM speed. And the input V in here, input voltage, DC voltage, here I am giving 200 voltage. When I am giving 200 input voltage, when you are sending that supply through this element, resistive element here I added, then here the voltage drop will be very less. If it is a impedance means the voltage drop will be more. Here I added a small resistive element, the voltage drop will be minimum. And here the induced EMF, when you are giving the input supply to the particular machine, So definitely induced EMF will be produced, right? So the induced EMF E or back EMF also you can consider. So 198 voltage, 198 voltage. Now I need to reduce the speed of the machine. I need to reduce the speed of the machine. This is synchronous speed, right? NS, this is speed of the motor, you can consider with NS like that. You can see here N is 1500 RPM and E here 198 voltage. Now I need to reduce the speed of the machine. At that point, the induced EMF will increase or decrease. The induced EMF will increase or decrease. You can see here, the machine is running with 1500 RPM speed. So some people, yeah, we have different thoughts. So we can focus on with the DC machines, then the AC machine also we can focus. Some people are, they need to build to develop in their electric vehicle DC machine, right? So at that point, we need to know the machine operation, whether it is effectively operating or what are the drawbacks of there in that machine. So if I use this particular machine, whether I can give more benefits to the customers or not. So now if you people are selecting a DC separately excited machine, here the machine is running with 1500 RPM speed and the induced EMF 198 voltage. Now you can tell me the induced EMF when I need to reduce the speed of the machine, reduce the speed of the motor, 750, half of the speed I need to reduce. At that point, 750 RPM. At that point, induced EMF will increase or decrease. You can recall once the DC machine. You can remember when your faculty will teaching. At that point, we have some mathematical analysis. If you are applying here KCL equation, KVL, then you will get one mathematical formula. You will write some mathematically also. So here, the induced EMF E, how you will write? If you know how you will write induced EMF E, induced EMF E, how you will write? Mathematically, how you will derive? Your faculty will draw this equivalent circuit and by KVL application and induced EMF E, you will get the final step 5 Z
done by 60 by P by A.
Yes, 5 ZNP by 60. Now you can see here, by observing this mathematical model or mathematical formula, induced EMF is always proportional to the speed of the motor. Is always proportional to the speed of the motor. If you are preferring to reduce the speed of the machine, 750 RPM, at that point, it induced EMF decrease. But to reduce this specific motor speed, you need to put some external burden, right? You need to add some external resistance. Let's take a e-rickshaw. If people are sitting 2 people in the e-rickshaw, at that point, the vehicle speed per hour 30 kilometer. 30 kilometer per hour. If you people are sitting, 4 people are sitting in e-rickshaw means, at that point, the vehicle speed will reduce, right? Definitely. That means when you are adding some external resistance, you can easily reduce the speed of the motor. You can reduce the speed of the motor. So here you can recall, you can observe in your surrounding. If you are at your home means, then you can observe how you are controlling the speed of the motor in the fan by controlling or by using the power semiconductor devices. The switch, through that switch you are controlling the speed of the motor, right? You have one controlling here. If you need to increase the speed 1, regulator. 2, 4, 5 like that you have, right? So you people are adding some external resistance, then you are reducing the speed of the motor. Now you can see here, what is the power formula? You can write V square by R external resistance. V square by R external resistance you can add. V square by R external resistance. So here, by adding some external resistance, you people are trying to reduce the speed of the motor. So now if you are reducing half of the speed means, then what is the voltage drop by adding the external resistance? By adding the external resistance, the voltage drop here you are getting 101 voltage. 101 voltage drop you are getting. If you are preferring the DC machines, 101 voltage drop you are getting. At 99 voltage only you people are getting as an input to the machine means, then it will consume more amount of the power. At long run, if suppose you need to use that particular vehicle or that particular motor at 3 years of the time if you need to fix. So then if this motor, if you are sending that 99 voltage and you are wasting in the middle of the network, your 101 voltage drop here going. So then consumption of the power will be more in this case. Consumption of the power will be more. And here you people are observing the DC machines. Here brushes are there and we need to add some external resistance also. Inside of the machine, stator part is there, rotor parts are there. Brushes and the rod. So the brushes will collect the current and it will send to the inside of the rotor. Then the commutation process will be done, right? But if you're clearly observing the DC machine, whether it's a DC generator or DC motor, here maintenance will be take more time. Maintenance, it will take more time, and the efficiency here you are getting the power, whether it is power efficiency, you are getting very low. Then you can observe the AC machines, whether it is an induction motor or synchronous machines, whatever the condition may be, whether it is a rugged condition or dry. If you people can utilize that specific AC machine, whatever the, whether it is a 100-degree temperature or minus degree temperature also you can utilize. So you can utilize that particular product machine in a rough condition also. So if you are using that also, and here AC machines case, the maintenance will be minimum and they have more robustness nature also. More robustness nature and less maintenance compared to the DC machines. Less maintenance. Very, if you are purchasing any AC machine, whether an induction machine or synchronous machine, you can utilize that particular machine 5 to 10 years of the long time. But the DC machines, you can recall once our forefathers or grandfathers, they are using when initial time around 2000 or before that 90s, they are using the DC machines in the agriculture purpose. And we have conveyor belts also there. And it will take, we need to keep with some diesel or kerosene, we need to keep in that particular method, then we need to operate. So always we need to monitor the machines. But if you are using the AC machines now in the water pumping system, whether it's agricultural pumping or water pumping system or in borewell system, if you are living in apartments, so you are turning on the switch. You don't know where the motor is there, but you are getting at your room, you are getting the water, right? So the AC machines, you people, they have less weight also compared to the DC machines. They have less weight and you will get according to your requirement, you will get the product also. So here compared to the DC machines, AC machines are more preferable and they give more efficiency and less noise also. Less noise also. What are those AC machines are using in the automobile industry? So nowadays, most of the automobile company, whether it is a Renault, in Chennai also Renault company is there, Audi company, or whether it's Altron or FCI, so many automobile companies are there in surrounding Chennai itself. So if you are observing whether it is Benz company or Ford company or Volkswagen company, the companies, most of the companies, they are preferring the AC machines only. AC machine. These AC machines, either synchronous and asynchronous, we are telling. The synchronous means here also, again, they divided permanent magnet synchronous machine, PMSM, we can call PMSM, or permanent magnet BLDC motor. Permanent magnet BLDC motor. AC machines means Tesla Model X type of car, they are preferring the squirrel gauge type of induction motor. Squirrel gauge type of induction motor. Tesla Model X or Tesla Model 3, and they launched their first vehicle. Tesla company, they launched their first vehicle, Tesla Roadster. Tesla Roadster vehicle they launched in 2008 itself. Now in USA, the one of emerging most superior or luxurious car is Tesla only. Tesla electrical vehicle only, they are emerged and better than the Mercedes-Benz company, better than the Mercedes in the automobile industry. Now in the USA, they are peak stage, Tesla company. They are planning to launch the Tesla electric vehicles coming 2021. They are planning. So we will see what will happen in coming years. So here we have squirrel cage type of induction motor, and compared to the squirrel cage and slip ring type of induction motor, squirrel cage induction motor only in all low and medium voltage application we people are using. So now these squirrel cage induction motors place, they are replacing by with the permanent magnet BLDC motor, brushless DC motor. So they are taking as a reference from the whatever the DC separately excited machine I discussed. From that, they are taking as a reference. From that, they are removing the brushes. They are removing the brushes, and inside of the rotor, they are keeping the permanent magnet. By keeping the permanent magnets, by keeping the permanent magnet machine, that permanent magnet BLDC motor, it will act as a AC machine only. It will act as a AC machine only, and compared to the squirrel cage type of induction motor or DC machine, this permanent magnet BLDC motor will work better than e-scooters or e-rickshaw or e-auto. You can go to the Google and you can search a permanent magnet BLDC motor. So Mahindra also, they launched the e-auto. They are using 800 wattage of the BLDC motor, permanent magnet BLDC motor. So here, now what is the present trend here, which type of technology they are preferring in today's world means the vehicle. So now we people will study in our graduation level, we people will study up to 3-phase machines only, but to run a cruise ship, if you are now most of the people are visited to the Chennai port, right? So you are located near to the port area, right? So if you are observing Chennai, big ships are there, right? To run that cruise ship, how much input power density you need to give. So to start this, you can, if you observe the MMTC local trains or express trains, if you are observing, they have different torque nature also. The machines also, we people are giving input power density more in the passenger train. Within the less span of time, within the 5 seconds, they will emerge within 70 kilometer speed also. Local trains or metro trains you can observe. So then the nature how within the less time, they are taking up to 70 kilometers speed like that. The electrical vehicle car also, if you are designing. So in that electric vehicle, if you are fixing the motor, within the range of the speed they will give, within the 0 to 7 seconds, the vehicle will take up the speed up to 100 kilometer speed or 120 kilometer speed also. So, but if you need to drive the cruise ship, which type of machine you people will prefer? Which type of machine you people will prefer? In the present world, the UK people or UK scientists, they are developed 15-phase type of machine. 15-phase type of squirrel cage type of induction motor they developed, and the British naval ship, they are developed 15-phase type of squirrel cage type of induction motor. For a 3-phase machine, how much input power density we need to give? The input power density, 3-phase motor or single phase means we will consider up to 230. If it is a 3-phase machine means more than 400. So if it is a 3-phase machine, we're keeping 400 voltage. But to run a cruise ship, you need to give more input power density. So what they will do in Japan also, in the bullet trains, initially the vehicles, they are within the less time they reach the huge amount of the distance, right? So they are connected the induction motor series connection they will do. So by connecting the series connection, they will take more input power density, then it will take huge amount of the speed also. But to drive this vehicle, a cruise ship, so if you are using the 15-phase type of induction motor drive, so then you need to develop a traction inverter like that. You need to develop a traction inverter also. So here, so in this, so in the middle of the sea also, they're focusing on to fix the renewable energy. They need to generate the electricity from the renewable energy sources, whether it is a wind turbines or solar PV panels. They need to generate the power, and from that, whatever the power they are generating, they need to store that one in the by using the batteries. They need to drive the vehicle in a safe manner. So then you can imagine 15 phase type of induction motor drive, if you are using in a vehicle means, then how much speed it will go if it is a less vehicle. So the electrical buses are already launched recently. Also, Indian government almost 8k electricity buses they given to mostly North India side they given. Now we will expect coming years in our Chennai city also most of the electrical buses will run. So the electrical buses, if you need to drive, or electrical truck, or goods and carriers, the vehicles, whatever the vehicles are there. So they need to, the motor, it will totally depend upon the motor. So you need to fix in your mind the machine model. So which machine you people will design. So whether, if you know the fundamental concept of the machines, whether the DC machines or AC machines, the fundamental three-phase machines, if you know, means according to that, we can build the multi-phase machines. Multi-phase machines we can build. And here, look at here, the types of the electrical drives in today's world in automobile industry are range extension and series hybrid drives. In a hybrid electric vehicle also, Chevrolet Volt company or BMW i3 company cars, they are preferring series hybrid drive mode only. Series hybrid drive, in a hybrid electric vehicle, there are three type of drive modes are there: parallel hybridization, series hybridization, combination of series and parallel, and micro hybridization also there. According to the drive mode, we need to build for in our vehicle the battery. The battery we need to fix. And here, Toyota Synergy Drive company, they are preferring full parallel hybrid drive technology, and mild or mild hybrid drive technology, they are preferring BMW 320D model, Audi A6 type of model. And battery type of electric vehicle, what are the companies mostly? Tesla company, they're focusing more on battery type of electric vehicle. Faraday Fisher or Jaguar I-Pace companies, these are focusing on battery type of electric vehicle. So look at here, mild or hybrid drive model, the range of the motor and what are the specifications here we can give. I can look at here, this Audi A6 limousine type of electric vehicle. To build this model, here they are preferring the 48 voltage of the battery. So the nominal voltage, you can check your mobile battery also. You can check your mobile battery. There is a nominal voltage is there, maximum voltage, how much you can store. Maximum voltage and the nominal voltage. So here the maximum voltage of the battery is 60 voltage and the nominal voltage of the battery is 48 voltage. And here we people are implementing to control the, we have AC system, right? Auxiliaries or e-custom, different type of parts are there. Right? We are watching the movies in our cars also, right? So we need to send different voltage levels to the vehicle also, not only machine. To drive the machine, we need to give more input power density. And in this type of model, the motor power range is less than 25 kilowatt hour, less than 25 kilowatt of the battery. And here they are preferring the lithium ion type of batteries. Lithium ion type of batteries. And here, if it is a micro or mild hybrid type of electric vehicle. So in this vehicle, the battery weight, it will be 20 to 60 kg only. 20 to 60 kg only. And the voltage, nominal voltage, you can see. That means the battery capacity may be around 10 kilowatt to or less than 10 kilowatt only. The battery capacity. That means if you are using that battery, one time if you are charging the 10 kilowatt of the battery, at least you can travel more than 100 kilometers or 150 kilometers. After that, if you are whatever the charging power is over, then you can utilize the fuel, you can reach the destination on time. So when you can utilize by using these hybrid type of electric vehicle, fuel and battery is there. So in this battery, and here they are focusing on the three-phase and multi-phase type of motors. They are focusing three-phase and multi-phase type of motors. They are preferring. There whether you can prefer the permanent magnet BLDC or permanent magnet synchronous machine or interior permanent magnet motor or switched reluctance type of motor or squirrel cage type of induction motor also. That is depending upon, you are the designer. Now you need to, when you are focusing to design means you need to know the fundamental concept. According to that, you need to fix which type of machine is more suitable for a specific electric vehicle. The model depending upon the model variation, the range of the motor or kilowatt, the capacity of the motor will definitely change here. Now you can see here the major components of the battery type of electric vehicle. So the battery type of electric, if it is a hybrid type of electric vehicle, the battery weight, it will be very less. The battery weight will be very less. And here we are discussing a hybrid electric vehicle. The battery weight and the battery input capacity also 60 voltage only. But if it is a purely battery type of electric vehicle, purely or fully electric vehicle means, then you can see here what are the components are there. You have charger and the batteries. The battery types here, we have majorly 4 type of batteries: lithium ion, lead acid, nickel cadmium, nickel metal hydride type of batteries. So lithium ion battery is more costly battery. Lithium ion type of battery cost is more because the lithium ion resources are not available in Indian market. In India, as of our geographical nature, we don't have that raw materials. Most of the raw materials are available in European countries or in Australia, lithium ion resources. But we have more than 2.8 million tons of the lead acid type of batteries or lead acid resources are there. Lead acid resources are there. You people will, most of the, in our surrounding area, we people will use lead acid, Amar Raja battery or Amaran type of batteries we people are using, right? You can see here, you have the battery and the controller nature and you transmission motor. The motor and here the DC converter, right? DC converter. What are the parts we can implement where we can work means here the battery backup, we can work on a battery pack technology or battery management system we can work. Traction inverter. So traction inverter case you people can work, and traction motor case and onboard charger. So either the range they will give, the client they will give they need 3.3 kilowatt or 11 kilowatt of the battery. And the DC converter, 3 kilowatt of the DC converter we need for this particular battery type of electric vehicle. And this one, you need to develop the control system also. You need to develop the control system. So if you, by observing all these components, how you can build and what the range here they are fixing 400 voltage to 800 voltage. So if you are using a battery type of electric vehicle and the battery capacity here, you may fix here 40 kilowatt hour up to 70 kilowatt of the 70 kilowatt hour of the battery backup also there. So one time if you are charging this type of battery, you can easily travel more than 500 kilometers also. More than 500, that means from Chennai to Madurai, at least it will take 6 hours of the journey, right? You people easily, one time if you are charging, then you can travel. So then for one time if you need to charge this 40 kilowatt of the battery, means it will take 12 in between 20 to 40 units of the energy it will take. Then you can see here 20 units of the power, how much cost you can estimate. So if you are traveling from Chennai to Madurai, so 6 hours, more than 6 hours of the journey, right? So then how much cost, how much fuel you need for a petrol vehicle or diesel vehicle, then according to that you can fix how much economically how much you are facing. If you are using an electrical battery, if you are charging one time at your home itself, you can charge. At your home itself, you can charge this vehicle. We have different type of charging station also. And the Indian government, they are focusing in all highways, all NH5 or NH7 or NH, from all the highways, every 50 kilometers, coming years, they are focusing to shift or to install the electric vehicle charging station, whether it is a solar vehicle charging station or AC charging station also they are focusing. That means every 50 kilometers. So we need to avoid, if the government, they are focusing on the electric vehicle and they are giving the commands and they are forcefully give the orders to shift to the electric vehicle, means according to that we need to arrange, right? So if all the persons are purchasing the electric vehicle, means where we can charge. So whether the electricity is available in our surrounding or the cost you can estimate. Wait a second. Now you can see here instrumentation and MR, not only electrical engineers, the electric vehicle dynamics, mechanical engineers work, instrumentation engineer will work, and the automobile engineer also will work. So electrical engineer, what is our role means, here we are showing the specification, whether we can implement the onboard charger, whether we can work on a charging station, electric vehicle charging station we can work on a traction motor or traction inverter. So to build, so these vehicle tires, these are all the parts that will come, sir, for other engineering persons, they will develop. But these are the parts, whatever the parts or whatever the components here I am showing, in these parts we can work on. Now you can see here. Now, what are the components of the electric vehicles? You can see here the batteries, and you can utilize the fuel cells, supercapacitors, solar panels also you can. On top of the vehicle, if you are fixing the solar PV panels in the vehicle, then when you are traveling in the daytime, you can generate the power. By generating the power, you can directly utilize that power. And if you are getting more excess amount of the power, we can store that power in the battery. We can store that power in the battery here. So why we need the traction inverter means, then again here we are raising one question. You people are storing the energy in the form of DC only, because you people can't store the AC power. All in our, whether it's a laptop or mobile batteries, we people are storing the energy in the form of battery only, DC power only we are storing, right? So the DC have unidirectional power flow nature, AC bidirectional power flow nature, right? So DC only you can easily store in your battery. Then how you are converting? You can imagine you people have adapter, right? In your mobile battery or laptop charger, you have adapter, right? Through that adapter, you are converting the AC into DC. Through that adapter, you are converting the AC into DC. How much input supply you need for your vehicle, for your mobile battery? Maybe 3 amps or 2 amps, right? How much battery input voltage it will take? 3.8 voltage. If you are overcharging means, some cases there may be chance to damage the battery or damage the mobile also, right? So you need to focus to develop an onboard charger. The vehicle you need to charge from the utility grid. That means from at your home, like how you are charging your mobile, in the same way you need to charge your electric vehicle also. You need to put a plug in the plug board, then you need to charge. Like that only. You have three. Now how we are charging our gadgets, electronic gadgets, like that only people will charge the electrical cars also. But how much time it will take? That's a big question. You people need to charge a 2000 or 3000 milliampere hour of the battery. Whether you people are using the Realme or Oppo or Moto, or whether whatever iPhone if you are using, how much time it will take to charge your mobile battery? It will take 100%. It will take 2 hours of the time, right? If it is a fast charging device, means within the 50 minutes if people are charging. So for that reason, we need to develop the onboard charger, fast charging. That's a big area we can focus more, and we can develop, and we can do more research analysis in the onboard charger cases also. And here DC-DC converter topology. Why we need the DC-DC converter topology means, we need to transfer between the high voltage and the low voltage. From the battery, you have 400 to 400 range voltage you have in the battery. But the motor need high amount of the voltage, but the AC at your car, AC you have, and the music system you have, that ECUs, body control ECUs and auxiliaries, air conditioning system or cabin heating system, they need different type of voltages. So how you can balance these voltage levels means, so directly if you are connecting to the AC 400 voltage means, so it can't operate, right? Then maybe it will damage immediately. So the required power only you need to send. So that's the reason here we are using the DC-DC converter topology to balance the high voltage and low voltage battery, right? You can see here the different type of chargers you can look at here. We have different type of chargers. The level 1, level 2 and level 3 charging stations here we are giving. So actually how much amps people are giving to your mobile battery? Either 2 amp battery, 2 amp or 3 amps only. But in the level 1 case, you can look at here the types of charger, charging code. This one is from source is from the Roper ID. Level 2 charging station from the Clipper Creek, and DC fast charging stations source from the EV Carol. If you are observing here, in the level 1 case, we can take 15 amps of the power if you are giving to the vehicle also. Level 1 case, how much time it is taking? 20 hours of the time it will take to charge a 24 kilowatt of the battery. 24 kilowatt of the battery in your vehicle, if you are using a 24 kilowatt of the battery, whether it is a plug-in hybrid or battery type of electric vehicle, if you are using 24 kilowatt of the battery, to charge that 24 kilowatt of the battery, in level 1 case, it is taking 20 hours of the time. That means if you are planning from Chennai to Kanyakumari, so before one day you need to charge the whole vehicle, right? So 20 hours of that, before 20 hours, you need to charge the vehicle, then you need to start your journey. In the middle of the journey from Chennai to Kanyakumari, more than 12 hours it will take. So to travel that much distance, if it takes 20 hours of the time, if the middle of the journey, if people are, the battery is over. So then if it is taking 20 hours means, or at least to charge half of the battery, it will take 10 hours of the time. Then the people, you are the customer. Now you people are more interested in the electric vehicle. Now you are purchasing the electric vehicle. In the middle of the journey, it gives some trouble. Then you people will get some annoying, right? Definitely. You people at that point, you people will feel bad about that electric vehicle and the charging system in the vehicle. So 20 hours of the time it will take means, then how to reduce the charging time? So that's the reason the charger, onboard charger or fast charging devices we need to implement. If you go with the level 2 charging station, level 2 charging station, 240 voltage and 40 amps if you are giving also, it is professionally if you are installing that type of charging station also, it is taking 7 hours of that time. 7 hours of the time it will take. But in the same way, if you are implemented the DC fast charging device, that means onboard charger, if you are implemented, the DC charging station, within 30 minutes you can charge your vehicle. Within 30 minutes of the time you can charge, and how much amps you can take? 125 amps people are giving within that time. 125 amps. 2 amps or 3 amps chargers only we people are observed. Coming years we people will see in real-time product like this onboard charger we people will see. If you are visited to the Bangalore or any metropolitan city, then you people will observe this charging station and the amps, and practically people will get some idea about these charging chargers also. And you can see here what are the companies all over the globe. AC charger socket, DC charger socket. We have different type of charger socket, AC and DC charger socket. Here we are giving some companies charger socket. Japan and USA, they are using Ezaki socket. Ezaki socket company, and the standard one JSAE 1772 standard. This is purely AC charger socket. So you can get how much? This AC charger socket, you can convert the AC to DC, and in the middle of, you can easily, how much amps? 32 amps from using the single phase only. 32 amps you can give to your vehicle to charge that one, and this is single phase. Mostly they are using in the Japan and USA. And a MEENAKSHI socket, you can see here the pole like this only we have 44 kilowatt of the battery and 63 amps and 3 phase. 63 amps you can give. And Europe, mostly Europe, and especially in German, they are using this type of charger socket. Lee Grande socket, 22 kilowatt of the battery, 32 amps, 3 phase. France and Italy, they are using Lee Grande type of company sockets. And you can see here DC charger socket, Chardemo, 400 kilowatt up to 1000 volt, 400 amps. 400 amps within the time if you are giving means within a less span of time you can charge your vehicle. So CAN protocol, it is a nothing but a bus system. At one point, all the parts of the vehicle will be connected here. And mostly Japan and Korea, they are using, what are the companies they are preferring means Nissan Leaf, Kia Motor. Kia Motor already they started their manufacturing in Andhra Pradesh, and Mitsubishi company. Nissan Leaf company, it is from Japan, 1930, it is established. More than 100 countries, they have franchises. And Nissan Leaf type of vehicles and manufacturing, in India also they're manufacturing. And DC charger sockets you can see here, GBT and 237.5 kilowatt, 950 voltage and 250 amps, and China and India. In India, Mahindra company, Chinese electric vehicle company, they are using these type of charger socket. Tesla supercharger you can see here, 135 kilowatt, 410 voltage, 330 amps. 330 amps of the power you can easily get from this charger, Tesla supercharger. And Tesla charging stations only you can fill, and Tesla S and Tesla 3. Tesla S model, Tesla 3 model. Tesla 3 model car itself, the cost around $30,000 to $40,000, in between the range. So the compared to all the electric vehicles, Tesla chargers cost is huge, because they are preferring the battery type of electric vehicle and more advanced features. Whatever we people are imagining in our mind, like that you will get the more flexible and luxurious cars in the electric vehicle domain. In automobile industry now, if the luxury car means people will feel Benz, BMW, like that, right? Now Tesla is trying to take over the automobile industry also, but they are focusing now due to the cost issue. So luxurious cars, which people will can buy? Only the rich people will only buy. But if you are providing the electric vehicle in an affordable price, then you can reach the middle class and the lower middle class. If you are reaching means, then globally you will become the number one. So you need to think like that. So how to reduce the cost of the product? When you are trying to focus to implement a product, then you need to think like that, and you need to introduce the vehicle also with a less affordable cost to all the people, with a high efficiency. And the car also we need to fix more with an advanced technology. We need to fix that one. You can see here the types of EV charging station. Level 1 we can call it a residential one, level 2 commercial one, level 3 one is DC chargers. So that means 30 minutes of that time, by summarizing all these points, 30 minutes of that time at least people will take break, right? From 12 hours of that time when we are traveling, in the middle of the journey, at least we will take for tea break 30 minutes at least. So within the 30 minutes, you can charge the vehicle means, then again you can travel more than 500 kilometers also, right? So you can see here. And to develop a onboard charger, you can look at here. We have a high voltage battery. Here we have a high voltage battery and different type of DC-DC converter topologies, and AC to DC converter, AC to DC, and the grid filter here we are using. Why specifically here we are preferring the filters means, if you are observing the either DC-DC or AC to DC. So if you are this battery, right? So from the battery you are taking the power supply. This DC-DC converter, it is not related, comes under the isolated DC-DC converter topology, and this one is a DC to AC converter topology. So here, if you people are preferring to implement these type of onboard chargers for your electric vehicle, then you can see here how and what are the switches you people will prefer. Whether you people will prefer the, we have different type of switches, bidirectional switches are there, unidirectional switches also there. Which switch you people will prefer? The power semiconductor devices, power electronics, so people will study it, right? So in those power electronics, when we are observing the power electronics also, when the power electronics are introduced in the market, in the industry, then the product size become very less actually. The product size will become more less, and we have the power semiconductor switch. It have fast switching nature, and the ideal condition of the power electronic switch losses are zero. Ideal condition of power electronic switch losses also zero. So to implement a onboard charger, now you have some idea to develop that charger. So then you are preferring the DC-DC converter topology. In those DC-DC converter topology, what are the available converters are in the market? So then what are the drawbacks you need to identify? The problem statement you need to identify. From that, you need to develop a unique one or a novel new converter topology for your electric vehicle application here. And here you can see gets commands from the battery management system and vehicle ECUs. Here the power factor correction converter or isolated DC-DC converter. So the isolated DC-DC converter topology, how to implement for the electric vehicle. And here we have different type of modes in the electric vehicle also, grid to vehicle and vehicle to grid and vehicle to load also. So from grid to vehicles means we can charge the vehicle from the utility grid with wire or wireless charging also. With wire or wireless. Now we people are charging all our devices with a wire only. So wireless charging system also, it is one area to do more research analysis in the less components. In a less smart devices already wireless charging technology already implemented. MIT research scholars, they are already done by taking the reference from the Faraday's laws of electromagnetic induction principle only. The magnetic induction, electromagnetic induction principle they are applied, and then sending the power without connecting any wire from primary coil to secondary coil. They are sending 60 wattage of the power without connecting any wires. Without connecting any wires. So whether we can charge the vehicle without wires. So in that way also we need to think. So that is one area to do the research also. And here utility grid and vehicle to grid also. Vehicle to grid where power is supplied from the vehicle to grid. That means suppose you people have some energy in the electric vehicle battery. From that battery you need to utilize all the loads at your home. So from that also you can take a vehicle to load mode. Vehicle to load mode, so you can take the power supply. So then you can utilize all the loads. If any due to the power interruption cases, you can utilize the power from the vehicle battery itself. And the standards you need to follow SAE J1772 CHAdeMO type of these standards if you are following. According to that, you need to build the vehicle onboard chargers also. So to implement the onboard charger, what are the fundamental direction DC-DC converters are there? Now you can see here the adapter you people are observing in the laptop charger or mobile battery charger adapter we people are observing. When you people are implemented a onboard charger DC-DC converter topology, the product will comes like this. The product will be, it will be like this. We can easily carry, right? The compact of the size we can reduce minimum by using the power semiconductor devices. What are the type of topologies we people will study in our academic year? What are the advanced topologies are there in the industry? Now you can see here the DC-DC converter topology, bidirectional DC-DC converter topology here we are giving. And in this classification also non-isolated topology, isolated topologies are there. So in a non-isolated DC-DC converter and the difference you need to know isolated topology. So we people will study, right? So now you people will tell me the non-isolated DC-DC converter. What is the difference between the non-isolated and isolated? Non-isolated and isolated. You people tell me. Now you can see here I will draw, we people will study these DC-DC converter topologies in our academic year. You can see here. and this is a diode, and here capacitor, and here this is load. Suppose from this is battery or DC voltage source, you can fix it from DC to DC. So which type of converter? This is source and this is load. Whether from here, from source to loads, if I need to send the supply, so by using the elements, by using this inductor or a power electronic switch here, this is a switch here, S1 switch. So now when you are turning on the switch, what will happen? When you are turning on the switch, this is a closed loop path, right? When you are turning on the switch, you can apply the KCL or KVL here. Now you can see here, when you are turning on the switch, what is the purpose of inductor and capacitor? Inductor will charge. When you are turning on the switch, inductor will charge here. When you are turning off the switch, inductor will discharge. Charging, discharging, charging, discharging. Like this you will get. Then actually DC means like this, right? DC voltage you are giving like this. But the output here, what happened? The inductor and capacitor, they will not allow sudden changes. You can write here L di by dt. L di by dt you can write it. You can see here charging and discharging. So here, if suppose at output side, you need to minimize the ripples. You need to minimize these ripples. The peak to peak voltage, delta PP maximum you will write. Delta PPP maximum you will write. And here delta, you can see here peak and minimum. Peak maximum and minimum here. You need to minimize these ripples, either 5% or 10%. 10%. That means at load side, you need to send the very less ripple voltage only. You need to reach the voltage like this, then it should be settled down like this. Constant way you need to settle down. Like this, if you are getting or if you are giving like this output voltage to any load if you are connecting, then the product will not come long life. The ripples if you are getting more means the product will not come long life. And here we are telling power factor. When you are purchasing AC or refrigerator, they will give how you people will purchase the product in when you are ready to purchase a particular product in Amazon or Flipkart or Snapdeal. What you will observe? Star rating, right? Star rating you will follow. According to that, you people will purchase which product have good star rating, either 5 out of 5, 4-star rating. Which product have means then you people will choose like that, right? So if you are implemented a product like this electrical product, you can observe when we are purchasing the electrical product, the star rate we no need to follow with the star rate. Power factor, whether the power factor is near to unity or not. Whether the power factor is near to unity or not, we need to think. So if it is less than 0.6 or 0.7 means, then it is not sending a quality amount of the power. So here, this is a basic converter topology. We can call this one as a step-up converter. Step-up or boost converter we can call. So here, when you people are giving the supply, it will turn on. And here, why I keep the capacitors mean, why I keep here across the load, why we are placing the capacitors mean to minimize the ripples, to minimize the load voltage ripples. Output load voltage, here the input side we are getting like this. The inductor is charging, then it will send to the through the diode, then here you will get it. When you are charging the inductor, capacitor will discharge. When the switch will off, at the time closed loop path, how it will be? When the switch will off, switch will off means a closed loop path you will get like this. This is the closed loop path, right? You will get like closed loop path. So here, if you are keeping the capacitor across the load, you can minimize the ripples. You can easily minimize the ripples. So and here, when you are keeping the inductor and capacitor, electromagnetic EMI, electromagnetic interference. electromagnetic interference you need to avoid, and noise problems also you need to avoid. Now you can check your earphones also. Whatever the earphones you people are using, in those earphone also, if you are getting annoying, if you are getting some annoying, or when you are, how you are increasing the voice, you have amplitude modulation, frequency modulation. In your earphone also, they are giving some inductance and some capacitance. Some inductance and capacitance also they are giving. So if you are using a company product, then you will not get any disturbance. If you are purchasing any local market product, then if you are listening the songs or if you are watching the movie through that earphones, after some time you people will get some ear pain also, due to because of the more distortions while we are using the earphones, our ear will get more pain. So these are all more sensitive parts, right? So you people will affect easily. So try to avoid the, you try to go through the standard product. Look at here. So this one is here. Whether this one is non-isolated or isolated, you people tell me. Whether whatever the step up converter or step down or combination of both, you people will study it in our academic year. Whether this boost converter or step up converter, whether this one is non-isolated or isolated.
It is non-isolated.
Yeah, non-isolated, right? Whenever we people are sending the supply by using a DC link path, we can call it as a non-isolated. So in an isolated DC-DC converter topology, we people will transmit the power from the source to load side by using a linear or ideal or mutual inductance. Linear transformer or ideal transformer, we are sending the power supply from primary to secondary side. So in a high power drive application or in onboard charger application, most of the companies, they are focusing on isolated DC-DC converter topologies. Isolated DC-DC converter topology. But to understand these isolated DC-DC converter topologies, whatever the smart devices we people are using, in all the smart devices, these non-isolated DC-DC converters only they are implemented, whether it is a step up or step down converter. But if you are getting the low amount of the voltage, you need low voltage. Your mobile battery need 3.8 to 5 volts. Your laptop, it may be around 12 voltage. So then you people are easily converting 230 to 12, right? You are converting AC to DC, then again you are step down the voltage levels. In all our electronic gadgets, we people are using the non-isolated DC-DC converter topologies only. But to charge an electric vehicle, we people are preferring, automobile companies, they are preferring the isolated DC-DC converter topologies. So what are the types of the converter topologies here we have, and the specification of those isolated DC-DC converter topology, you can see here. Here we have buck and boost, buck boost, cup converter, sepic and zeta, flyback converter, right? So if you're observing here, buck converter or boost converter, in buck and buck boost converter, here the power factor you may get near to 0.62 or less than 0.7. Why we are focusing on the cup type of converter? So the buck boost nature only the cup converter also have. In the cup converter inverter topology, cup converter DC-DC converter topology, the input current ripples. So if you are observing the inductance, when you are charging the inductors, here how you are getting more ripples here I am showing, right? So like that, if you are using a cup converter topology, you people will get very less current ripples only. Less current ripples if you are getting means, then you can say the product, whatever the product you are working, it's a good product, cup converter. Input current ripples and the output current ripples will be minimum in this one. And here SEPIC, single-ended primary inductor type of converter topology or zeta type of converter topology, the switching power losses, the output power switching losses will be minimum. Suppose if you need to implement a 500 wattage of the DC-DC converter for your specific product, you are trying to implement a 500 wattage DC-DC converter you are implementing. If you are working on with the SIMULINK type of converter topology, the output power 500 wattage means you may reach near to 460 wattage of the power also you may get at output side. The less amount of the switching power losses only while you people are using the SIMULINK converter topology. The flyback converter topology, it comes under the isolated DC-DC converter topology. How the isolated DC-DC converter topology are to implement a onboard charger and a DC-DC converter topology, the controlling and packaging techniques. You can see here the fast switching and low loss devices and galvanic and silicon based devices only people are using. The switch selection of switch I said, right? Which type of switch you people will select, whether you people for your particular product you people will prefer the MOSFET or IGBT. That one question you need to raise. What is the advantage of MOSFET and IGBT? So while if you are using the IGBT, how the power losses, while you are using the MOSFET, how the power losses. Both MOSFET and IGBT will comes under the voltage control devices. But the BJT it comes under the current control devices, and the IGBT and MOSFET they have bidirectional power flow nature also. But which switch you people will prefer for your to develop a DC-DC converter itself? If suppose it's a simple DC-DC converter you need to implement, then which switch you people will prefer for your particular product? And here, what are the better packaging technologies you people will use here? We will see. And look at here, the isolated DC-DC converter topology, basic topology you can see here, the flyback converter. While you can see here, the isolated, so linear transformer or ideal transformer or mutual inductance we can apply. So here, these are the basic topology based on the isolated, whether it is a flyback or cuck or push-pull or forward type of topology, but the full bridge based, the full bridged or LLC or resonant type or phase shifted DC-DC converter topology we will see here. So to implement a full bridge or off bridge DC-DC converter topology, full bridge or onboard charger, to implement onboard chargers, most of the companies they are focusing isolated DC-DC converter. So Eaton company, Switzerland, from Indian company KPIT, and Micro Fuzzy from German, they are working on the isolated resonant type of converter topology, isolated phase shifted DC-DC converter topology to implement a electrical bus or electric vehicle onboard charger to get a patent rights. So they are working towards product. So which type of converter topology people will work and how you people will implement the product also you need to think here. So apart from all these isolated type of topologies, so LLC and phase shifted DC-DC converter topologies are more preferable, and high power applications, these LLC and phase shifted DC-DC converter topologies are suitable. So while you people are traveling from the trains, electrical trains or electrical buses, so you people are charging your mobile phones also, right, nowadays. So how we people are trying to getting very low amount of the voltage, because the electrical train it needs more amount of the power, right? So to travel within a long distance also. So at that point, electrical buses to charge means we need to charge our vehicle or to charge the particular vehicle. So the onboard charger here, we are using the LLC or phase shifted DC-DC converter topology. Compared to this isolated LLC resonant DC-DC converter or phase shifted dual active bridge type of converter topology, the LLC resonant type of converter topology, it gives 95% of the efficiency in the converter. It gives the 95% of the efficiency. Now you can see here, what is meant by resonance actually? What is meant by resonance? Resonance, you people will hear that name when you are studying the electrical or network analysis, the resonance, series resonance, parallel resonance, right? What is meant by resonance? You can look at here, before the ideal transformer or linear transformer, across here, series and parallel, we people are keeping the L and C, right? LC we are keeping in series and parallel. Now you can tell me what is meant by resonance. At a particular frequency, the magnitudes of both inductance and capacitance both are equal each other means then we can call the resonance. It will applied here. So the resonance you can see here, XL parallel or series resonance. So both you need to equal each other means XL is equal to XC. So XL you can write omega L, XC 1 by omega C, but L is always inversely proportional to capacitance. So you need to, at a particular frequency, you need to equal each other or cancel each other. The magnitudes of both inductance and capacitance, you need to equal each other or cancel each other, the magnitude. At that point, resonance concept will apply. When you are getting the resonance concept, you people will get the pure sinusoidal waveform as an input. Pure sinusoidal waveform of you people will give the input of the ideal transformer, this transformer. Then again, by using these power electronic switches, you can control the AC into DC and you can send the power here. You can send the power here. The switching frequency also, you can observe your earphones. You people are using 50 to 20 kilohertz of the switching frequency. Frequency modulation you are applying. So frequency while you are modulate changing, then according to that you are getting flexible sound also. You can see here more than 250 kilohertz switching frequency we can use in the isolated LLC resonant type of DC-DC converter. And here this converter topology, it is possible to both zero voltage switching and zero current switching also. So my question for you for tomorrow session, what is zero voltage switching and zero current switching? And here to implement a LLC resonant converter or phase shifted dual active bridge or full bridge DC-DC converter topology, which switch you people will prefer? What is the whether MOSFET is good one or IGBT is preferable? Which switch? It will give more efficiency? You need to know. Then you can answer me. And the phase shifted dual active bridge converter you can see here. This phase shifted dual active bridge converter, it will give, or we can call this one as a dual active bridge type of converter topology also. This dual active bridge type of converter topology, it will give you can see here this dual active bridge converter. Here we are using a battery and here 380 voltage. Now this DC bus voltage, suppose 380 voltage here you have. By using this 380 voltage, you need to get for your battery 48 voltage. In a hybrid electric vehicle, Audi A6 car, when I am discussing limousine type of model, 48 voltage battery they are preferring. So this battery, so the battery here you need to get 48 voltage. So how you people will control the flow? So these converter topologies bidirectional power flow nature, whether you can move in forward and backward also. Whether you can move forward and backward, right? How you people will send the power to the motor or drive application in forward direction and negative direction, power flow direction, both I will show in the MATLAB SIMULINK model. We will try to design this converter. Here also we have voltage control technique, current control technique, power flow control technique. We have different type of control techniques also there. We will design this phase shifted dual active bridge converter topology. Voltage control technique we will design. Then we will move to the power flow control technique. So my suggestion to all of you, if you have LAPI, you please install the MATLAB. I will share the MATLAB software link for you. You people please install the MATLAB software. Then tomorrow session, we people will discuss about the MATLAB SIMULINK design, the basic I will tell. Then we will go with the MATLAB by using the MATLAB SIMULINK software, how to develop a onboard charger for an electric vehicle application. For an onboard charger, how to implement. Then we will see how to implement the traction inverter and how to operate the motor. Those things we will see. But you people just install the MATLAB software. You just install the MATLAB software. Then tomorrow session we will, with the fundamental concept of the MATLAB, then we will teach how to develop a onboard charger or dual active bridge or phase shifted dual active bridge converter topology. I will discuss and I will try to design with, along with me, you need to practice in your MATLAB SIMULINK software. Along with me, you people will also practice. Here I will tell to what is the single phase shift technique, extended phase shift technique, dual phase shift technique, triple phase shifting. So different direction and the power flow, how it we will send. So these phase shifted dual active bridge converter only now a more advanced one in the onboard charger application. So before designing this phase shifted dual active bridge, the basic model also, the non-isolated DC-DC converter also we will see. So you just once you can go with the fundamental. Already if you are a third year or final year, you people have some idea about the power semiconductor devices. So in that one, choppers, you can call it as a chopper or DC-DC converter. Those fundamental concept you just go through, and the mathematical concept you just try to get it, the mathematical concept. So here the MATLAB SIMULINK model, if you know the mathematical, the rating of the power converter. Here I will show the 5 kilowatt. From that 5 kilowatt, we can develop a 10 kilowatt of the isolated DC-DC converter also. From 300 wattage to 10 kilowatt of the converter also we will develop it. But you just install the MATLAB and try to, once you can just recall the fundamental concept of the DC-DC converter topology. Step up, step down, combination of both. Those three concepts, you just once recall it. So then we will design that one. Then we will go through the full bridge or phase shifted dual active bridge converter topology. So for all of you, once again, thank you all for spending your valuable time for attending this webinar. And I wholeheartedly thanks to the department head, HOD madam, and the coordinators for arranging this session and giving this opportunity to Pantech e-learning. I hope you people are enjoying the session. If you have any queries regarding the session, you can please ask. So whether the communication or any technical issue, or if you have any queries, you can please ask in the chat box or WhatsApp group also. You can send a message regarding this. If you have any queries, whether it's a hybrid electric vehicle or battery type of electric vehicle or plug-in hybrid electric vehicle, from that, the specific application we will design in the tomorrow session by using the MATLAB SIMULINK software. I will share the SIMULINK software to your group. Then if people go through the link, then try to install the MATLAB software in your PC. Then we will start to design the models in the MATLAB. MATLAB features, so whether it's a Renault company, all the automobile companies, they are following the MATLAB. So the basic model, whether if you need to implement, the model. So I said mill, sill or hill. So whether after completion of the graduation, whether when you are working on a MNC company, whether you people will work in a product, that means mill test or hill test or hill test. So model in the loop, software in the loop, hardware in the loop. Hardware in the loop is the final stage. So we people will work on the prototype boards, right? Like that, in real-time simulation or real-time product, when it comes to the market, all the automobile companies, they will follow these scripts: mill, sill, hill. So there may be a chance you people will place a mill test or sill test or hill test. So then where you people, but to place or to work in the MATLAB SIMULINK before that company, you need to know the fundamental concept of MATLAB SIMULINK software. So by using the mathematical equations, how to develop, how to build the model in the MATLAB. If you have some equation, mathematical equation, I said non-isolated DC converter topology. If you are deriving the mathematical equation, so the V naught, how you will get V in by 1 minus D. So then if you are applying the KVL, so then you will get one mathematical equation. You will get the inductance formula, capacitance mathematical formula. So from that, if you have a equation, you can build easily by using the SIMULINK inbuilt blocks. So the model design we will see in the tomorrow session, the non-isolated, isolated DC-DC converter topology, we will see, and sharp 10 a.m. we will meet. So all of you, please install the MATLAB software. I hope once again, thanks to the head of the department, Sundararajan madam, Department of EEE.
Sir, can I ask a question?
Yes, sir. You can ask.
Sir, you have discussed regarding the electromagnetic interference effect, EMI effect. So how it is eliminated in the isolated case?
Electromagnetic interference in the isolated DC-DC converter topology, sir.
Yes.
Here,
EMI effect and noise effect, it is eliminated in the isolated case, but it is coming in the non-isolated case. How it is eliminated in the isolated case, that I am asking.
Isolated and non-isolated DC-DC converter topologies, we people are using both converter topologies, but depending upon the product we are using. The electromagnetic interference or noise problems I am telling now. So the switching frequency actually, when we are using the SCR or BJT, at the time up to 100 kilohertz switching frequency only we can utilize. So nowadays in the MOSFET or IGBT switching cases, in the while if you are using the MOSFET switch, we can go through the more than 250 kilohertz switching frequency also. So we can operate the converter topology up to 250 kilo. When we are using 250 kilohertz switching frequency, so then we need to develop in the open loop model and the closed loop model also, sir. Open loop design we need to do. So while we are designing the open loop condition by using the pulse generator technique, so then if you are design the model, then you will get the output voltage, but you are unable to control the output voltage by giving the feedback path technique. So we have different type of control techniques also here we are giving. We have feedback control technique, PI or PID control technique, and the sliding mode control technique, dynamic evaluation algorithm, a digital controlling algorithm, or switching mode power supply also. Switching mode power supply. By using the different control techniques, we can try to minimize the ripples. That we can try to minimize the whatever the ripples at input inductance side or output current side or output voltage side, whatever the ripples we are getting, those ripples we can easily minimize by using the MATLAB SIMULINK software. So while we are working on the prototype board, sir, when we are working on the prototype board, that interface, when mathematically I said, right, sir, by using the mathematical equations, so then when we are giving input voltage 12 voltage, at that point if you are turning on the switch, either 50% of the switch you are turning on means, then you will get the 24 voltage of the output voltage on. That one mathematically, theoretically also we can derive. The same concept when we will design the model in the loop, then we will apply the closed loop feedback system also. And the switching frequency and the capacitance, so here we are adding the capacitance. By adding the capacitance, we can minimize the ripple. So that one I will show in the when we are designing the MATLAB SIMULINK software. I will show it, sir. And the electromagnetic interference and the noise problems also. Noise problem also. Prototype board, the same whatever we are designing the model in the loop, model based while we are testing in the open loop and closed loop, the same concept we need to apply in the software in the loop. SIL test, what they will do means by using the embedded C, they will apply, and by using the embedded test, and again they will analyze 10 cases, 10 different ways they will test. Then they model in the loop, SIL test, if we are satisfying, then we will shift it to the hardware in the loop. So in both three testers, MIL or SIL or HIL, we need to get the same output. The required output we need to achieve. Otherwise, if anything or any mistake are coming means, then again we need to verify with the model SIL or HIL. The 3 steps are there, sir. According to that, we can easily work on that particular product. So if we are satisfied with these 3 test cases, then we can directly go with the product, real-time product. All the companies they will go. Hello. Okay, fine.
Yes, sir. Okay, sir. Thank you, sir.
Okay, all of you, I will share the SIMULINK design. I will share the SIMULINK software. Try to install in your MATLAB SIMULINK in your lab. So we will start with the SIMULINK design in tomorrow's session. So go with the fundamental concept of the DC topology. From that, we will develop the full bridge converter or dual active bridge converter topology in the MATLAB SIMULINK software. Thank you all. Tomorrow we will meet. I will share the recorded session video. Then you can go through that recorded session videos. Thank you all. Once again, thanks to the management of
Thank you, sir.
MEENAKSHI Sundararajan College of Engineering and Technology. So have a nice day. We will meet tomorrow session.
Sir, today's session will be shared, right? Video
Yeah,
recording.
I will share the today's session recording video. I will share it, sir. So while I will conclude this one, I will record the video, then I will share it, sir.
Thank you, sir.